Hello there, Mr. Sutton here, bringing you the IM342 Extra Practice Number 2 solutions on the quadratic formula. To solve this quadratic equation, since we do not have any linear term, we can just use square rooting after we isolate that squared term. So to get this started, let's subtract 9 from both sides. That gives us 324 on the right side. And now if we divide both sides by 4 to get that x squared truly alone, well, let's see here. 324 divided by 4, well, 320 over 4 would give us 80, so this is 81. And if x squared equals 81, now I can square root both sides. So that leaves me with x equals, now let's see here, it would be 9 normally, but since I'm square rooting an equation, I also have to put the negative root in there as well, because that would also solve this equation. So this is going to be plus or minus 9. On this problem, since I have a squared term and a constant, I can solve this by square rooting both sides, and I can do the square rooting right away since my squared term is already isolated. So square rooting the left side, we've got 4p plus 1 with no square parentheses. That was kind of the whole point of square rooting it. And then on the right side, I'm going to have 9, but since I'm square rooting an equation, it's going to be plus or minus 9. I always have to remember the negative root when I'm using square root to solve an equation. And now I still have to isolate the p, so subtract 1 from both sides. That's negative 1 plus or minus 9. And then to get p by itself, we divide by 4, so negative 1 plus or minus 9 over 4. And since we are able to combine negative 1 and 9, we have to do so and reduce it to get our two different answers. So we've got negative 1 plus 9 over 4. That's going to be 8 over 4, which is 2. And then we have negative 1 minus 9 over 4. That's going to be negative 10 over 4, which I can reduce by 2 to be negative 5 over 2. On this problem, I'm trying to solve for x. Now, since I have essentially a squared term and a constant, I can solve this one by square rooting, but first I have to isolate that squared term. All I have to do to isolate it, though, is divide both sides by negative 2. If I do that, I have x minus 3q, or squared rather, equaling negative 10. And at this point, I can go ahead and square root both sides. So if I square root the left side, I've got just x minus 3, no square. And on the right side, there's a few things going on. For one thing, I'm going to have to write plus or minus square root because I'm square rooting an equation. And also, because I have a negative that's going to end up inside that square root, on this step, I'm just going to take that out right away as an I. So I'm going to write plus or minus I radical 10. And just one more step, isolate the x by adding 3 to the other side. So that's going to be x equals 3 plus or minus I radical 10. To solve this quadratic equation, we have a linear term, so solving by square rooting won't work. So whether we're trying to factor or use quadratic formula, we need to get everything on one side. Let me subtract 18x over to the left side. That leaves me with a 3x squared minus 18x minus 33 equals 0. And we have an a value here that is not 1. So we're probably going to have to use quadratic formula if we don't want to factor. But before we do any of that, are there any common factors that we can divide by? Well, these are all divisible by 3. So let me go ahead and do that. That leaves me with 1x squared for my first term. And then this will be minus 6x minus 11 equals 0. And now, since I have a value of 1, let me at least consider factoring this. Are there two numbers that multiply to negative 11 and add up to negative 6? Well, not so much. Our only choices for factors are going to be 1 and 11, and there is no way to get a 6 out of those. So quadratic formula it is. So that's negative b plus or minus square root of b squared minus 4ac all over 2a. And plug in some things in here. We've got a b value of negative 6, the coefficient of x. So we have negative 6 then, plus or minus square root of negative 6, quantity squared, minus 4 times the a value 1, times the c value, negative 11, and down below we have 2 times that a value of 1. Simplifying, we have 6 on the outside, and on the inside we have plus or minus square root of 36. And then, let's see here, we have negative 4 times negative 11. That's coming out to plus 44. All of that over 2 36 plus 44 is 80. We can definitely simplify 80. The biggest perfect square that goes into 80 is 16. 16 times 5. Square root of 16 is 4, so this is 6 plus or minus 4 radical 5 over 2. And 6 and 4, those are both divisible by 2, so we can actually reduce this a little bit to be 3 plus or minus 2 radical 5. For this problem, we have a linear term, so we're going to need either factoring or quadratic formula to solve this quadratic equation. Either way, I need to move everything over to one side, and I want to get it on the left side. I just prefer having positive squared terms here. So I can rewrite this then if I subtract the 4x and add 5 to be 8x squared minus 4x plus 5 equals 0. And this doesn't look like it's going to be a whole lot of fun to factor, if it even can be factored. So let me just go straight to quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. For my b value now, plugging everything in, we've got this negative 4 that's the coefficient of x. So that's negative 4 plus or minus square root of negative 4 squared minus 4 times that a value of 8 times the c value 5. And then we have 2 times the a value 8. Simplifying, we have positive 4 plus or minus square root of, this is going to be 16 in here, minus, well, let's see here. I can multiply these in any order. So 4 times 5, that's going to be 20. 20 times 8 is 160, so we're subtracting 160 from 16. And then we have 16 down below. 16 minus 160, that would be negative 144. Since I have a negative inside the square root, I can take that outside as an I. And then the square root of 144 is 12. So I can write this as 4 plus or minus 12i over 16. We're almost done, but I happen to notice that 4, 12, and 16 are all divisible. They're all reducible by 4. So reducing everything by 4, I can rewrite this as 1 plus or minus 3i all over 4. For this problem, we've got a quadratic equation that has a linear term, so I can't solve by square rooting. I might be able to solve this by factoring. If I can figure out two numbers that multiply to negative 91 and add up to negative 6. And it turns out there actually are two such numbers, but maybe you didn't know that. So let me just show you a solution involving the quadratic formula, because that'll work on anything, including things that factoring would work on. So we've got negative b. Well, actually, let me rewrite this with some coefficients clearly marked out here. So this is going to be 1x squared minus 6x minus 91. So we've got negative b plus or minus square root of b squared minus 4ac all over 2a. And for a b value, we have this negative 6. So that's negative 6. And then we've got plus or minus square root of negative 6 squared minus 4 times the a value 1 times the c value negative 91. That'll be fun to multiply. And then we have 2 times the a value 1. So this is going to be out here positive 6. We've got plus or minus square root of 36. And then 4 times 91, that's going to be 364. And negative gives me a positive there. And down below, that's just 2. 36 plus 364. Conveniently, that is 400. Nice round number there. And this is really good because 400 is a perfect square. This is 20 squared. So square rooting that, I have 6 plus or minus 20 over 2. And now I'm actually going to end up with two solutions if I simplify this a little bit more. So since I can combine 6 and 20, I'm going to do so. We have 6 plus 20 over 2. That's going to be 26 over 2, which is 13. And then we have 6 minus 20 over 2. That's negative 14 over 2, which is negative 7. So those are our two answers. Now, alternatively, if you spotted it, you might have been able to split this up in the beginning as x. Let's see, this would be x plus 7 and x minus 13. That would have added up to negative 6 if you had negative 13 and positive 7. But if you didn't spot that, then quadratic formula will also get you there.